Okay, so I have to integrate this by separating the variables. I'm going to replace. I'm going to move the. I'm going to move the square root of y over with the dy by dividing by it. I'm going to move the dx over with the x's by multiplying by it. And I'm going to have to tackle these separately. Now I'm going to integrate both sides. So on the left-hand side, that's the same as 1 over the square root of y, which is the same as y to the negative 1/2. And now I can just use the power rule, add 1, divide by the result. So that should give me 2 times y to the 1/2, or 2 times the square root of y. So plus some constant, but we're going to do that on the other side, remember. On this side, I'm going to treat this as, let's see, I can do 4. Actually, I can pull the 4 right out in front, can't I? And I can break all those things up to this. Well, I'm not seeing an easy way to evaluate that or integrate that. So I'm going to do a u substitution. If u is ln x, du equals 1 over x dx. And that tells me I can replace that with the du. I can replace that with the u. And I'm integrating times the 4. So the antiderivative of u is 1/2 u squared times 4 plus some constant. And I'm going to do my substitution now. I'm going to get 2 times the square root of y equals 4 times 1/2 is 2. I know that u was ln x plus some constant. I guess I could divide everything by 2. And c divided by 2 is still some constant, right? And I could square both sides. Actually, I'm not going to square both sides first. I'm going to do it this. I'm going to do this. I know that I have to find out what c is. They told me the point was E1. So if I replace 1 in right now, square root of 1 is 1, and the natural log of e squared plus c, well, the natural log of e is 1. So that tells me c is going to be equal to 0. So if I have this, now I can think that this is the square root of y equals the natural log of x squared, and I square both sides. That's going to give me the natural log of x to the 4th. And that's what the book says. Okay, hope that helps.